Uh, okay, today in 20-1, we're looking at the last topic in Chapter 6, Solving Rational Equations. Now we're going to split this into two parts. One was just going to do the mechanical part, and then in part 6.4b, we're going to look at solving these equations. When we look at solving these rational equations, what we're going to do is follow some certain steps. The first thing we have to do is to factor each denominator. Then we have to identify our non-permissible values. We have to multiply both sides of the equation by the lowest common denominator. And that is one of the key things that you're going to have to remember as we go through this whole thing. Then we solve by isolating the variable on one side of the equation and to check our answers. Just standard as we always do. In our first example here, I'm just going to rewrite it. What we're going to do is get x over 4 plus 1 over 3 equals 2x over 3 minus 1/2. When we look at 4 and 3 and 3 and 2, our common denominator, well, 4 and 3 both go into 12, and so does 2. So our lowest common denominator is 12. The next step is going to be to multiply everything on both sides by 12. Now when you multiply 12 by 4, or 12 by x over 4, 12 by 1/3, and all these fractions, you multiply the 12 by the numerator and then divide by the denominator. So 12x divided by 4 will be 3x, plus 12 times 1 divided by 3, so that's 12 divided by 3, which is 4, equals 12 times 2x is 24x. 24x divided by 3 is 8x. Minus 12, there's a minus sign there. Minus 12 times 1 is minus 12, divided by 2 is minus 6. Now, we have a regular equation we're going to solve. First thing we're going to do is subtract 3x from both sides. You get 4 equals 5x minus 6. Add 6 to both sides to isolate our variable. Divide both sides by 5, and you got x equals 2. There we go. In our next example, we have x over 4 minus 7 over x equals 3. Now our two denominators are 4 and x. We needed a common denominator for 4 and x, so that can only be 4 times x. So our lowest common denominator is 4 times x. That means I'm going to multiply everything on both sides by 4x. 4x times x is 4x squared divided by 4, minus 4x times 7, which is minus 28x divided by x. Notice the minus, equals 4x times 3 is 12x. Now, what am I going to do? Well, I'm going to cancel what I can cancel. To clean this up, the 4's are going to cancel to leave me with an x squared. The x's are going to cancel in 28x divided by x. And that's all I can cancel, so that's equal to 12x. Bring everything over to one side. So I'm going to subtract 12x from both sides, and I'm going to get x squared minus 12x minus 28 equals 0. Which of course is a quadratic equation. So we're going to factor that into two binomials, and two numbers that multiply together to give me negative 28 and add up to negative 12 have to be, well, 14 and 2, so negative 14 and positive 2. So it tells me that there's going to be two solutions. X could equal 14, or x could equal negative 2. We should verify that. Check it by substitution. Plug 14 into our original equation, so you'll get 14 over 4 minus 7 over 14 equals 3. So just use what you know about fractions. Reduce 7 over 2 minus 1/2, and 7 over 2 minus 1 over 2 is 6 over 2 equals 3. Well, 6 over 2 is 3, so that works. Now we can check the other one, negative 2. Negative 2 over 4 minus 7 over negative 2 is equal to 3. And that's negative 1/2. Minus 7 over negative 2 would be plus 7 over 2 equals 3. Negative 1 plus 7 would give me 6 over 2, which is the same as 3, so we're done. And our next one, 2 over z squared minus 4 plus 10 over 6z plus 12 equals 1 over z minus 2. What we have to do is factor first. Factor everything. Of course, I'm just talking about the denominators. There's nothing to factor on the numerators. We don't do that anyhow. Now when I look at what my denominator, my common denominator has to be, it has to have, well, a z plus 2 in it, it has to have a z minus 2 in it, and it has to have a 6 in it. So if I take my lowest common denominator, which is 6 times z plus 2 times z minus 2, and multiply that by every single term, all three terms, I'm just going to write that there in red beside each of those. Now I can start canceling. If I have a z plus 2 on the bottom, I can cancel that z plus 2 with the z plus 2 on the top. I can cancel the z minus 2 on the bottom with a z minus 2 on the top. And that leaves me with 2 times 6, or 12, for my first term. See how that cleans up? That's what we want to do. We want to get rid of the denominators. And our next one, notice that we have a 6 times z plus 2 on the bottom. So I can cancel a 6, and I can cancel a z plus 2, leaving me with plus 10 times z minus 2. Of course, that equals the other side, which is going to be, you can only cancel a z minus 2, so cancel those, and you're left with equals 1 times 6, which is 6 times z plus 2. So now we don't have any more denominators. We can just clean this up, and we're going to get 12 plus 10z minus 20 equals 6z plus 12. You can simplify the 12 minus 20 on the left side. And now we can start our row operations. We can say subtract 6z's from both sides. And we can add 8 to both sides. Now we can divide both sides by 4. And z is equals to 5. You can check it by plugging that back into your original equation. There's our original. Plug in a 5. 2 over z squared is 25 minus 4, so that's 2 over 21. Plug in a 5, you get 10 over 42 equals 1 over 3. Reducing, or putting the left side into a common denominator, we get 4 over 42 plus 10 over 42, and that'll give me 14 over 42, which reduces to 1/3, so it does work. In our next example, sometimes when you solve equations, you'll end up with an extraneous root. That means one that can't be used. So let's look at this. We have a k plus 2 on the bottom, k minus 2 on the bottom, and a k squared minus 4. Well, that's a difference of squares, so let's go ahead and factor it. Top we don't worry about. So the bottom we're going to get k plus 2 times k minus 2. So now my common denominator has got to have a k plus 2 and a k minus 2 in it. So if I multiply everything on both sides by k plus 2 times k minus 2, I will be able to get rid of my denominators. At this point, it's important to say that k cannot equal positive 2 or negative 2, because that's going to play an important role later on. So here we go. K plus 2 times k minus 2. When I multiply every term by that, notice on the first fraction, k plus 2's are going to cancel, and I'm left with 4k minus 1 times k minus 2. Next, the k minus 2's are going to cancel, and I'm left with minus k plus 1 times k plus 2. Be careful with the negative signs. Equals, this time both the terms on the bottom are going to cancel with the k plus 2 times the k minus 2, and we're going to be left with just k squared minus 4k plus 24. Okay, now we've got something that we're used to seeing. We just clean it all up. We're going to FOIL the first two, minus FOIL the second two. Remember, now you're subtracting everything inside of those binomials, equals our right side. When you clean this up, 4k squared minus a k squared is 3k squared. Negative 8k minus another k is minus 9k, minus 3k, positive 3k, and that'll be minus 12k. Then I have positive 2 minus positive 2, that's nothing. So that's just going to equal our left side of k squared minus 4k plus 24. Now, to clean this up, bringing everything over to one side, I'm going to have a k squared, 3k squared minus the k squared leaves 2k squared. Now I'm going to add 4k to both sides. Now I'm going to subtract 24 from both sides, and I have a quadratic equation that I'm going to start working with. First of all, I notice that I can divide everything by 2 to get k squared minus 4k minus 12 equals 0. Now I can simply use the sum product method on this, and I'm going to end up with k minus 6 times k plus 2 equals 0. So k can equal 6, or k can equal negative 2. But, it's a big but. Notice where it says k equals negative 2. If we go back to our non-permissible values, you'll notice that k cannot equal positive 2 or negative 2. That means it's not allowed, so you can cross it out. It's called an extraneous root. K equals 6 then is our only solution. I'd like you to stop the tape and complete the your turn, then start it up, and we're going to continue. This time we've got 3x over x plus 2 minus 5 over x plus 3. We can factor the x plus 3, the x squared minus x minus 6, and multiply everything by the common denominator of x plus 2 times x plus 3. Cross out what you can. Go ahead and solve it, and you're going to find you're going to get two roots. X is equal to 5/3 or x is equal to 3. But x cannot equal 3 from our non-permissible values, so you end up with one solution, x equals 5/3.